I'm going to introduce the company where this algorithm is working actually, the environment where it is giving its result. The company is BHG. It's a merger between two oil and gas company. One is Baker Hughes, Houston-based oil and gas company, and the other one is General Electric. So BHG is a $22 billion turnover company. Actually, we have 4 segments. First one is the oil field, and that is everything that an oil company needs to drill the land to get oil and gas. This may be on the land, subsea, or on platform. The services are serviced for spare parts fulfillment. Then we have digital solutions, that is all the digital solutions that allow the companies to control remote fields. And then we have the segment where we work in, that is the turbo machinery and process solution. That is a segment that is producing machines for the power generation and the compression of the hydrocarbon through the pipes. The turbo machinery, or TPS as we are going to call it, is working in 5 different environments: onshore, offshore, piping, LNG, refinery, and industrial. And it had, in the fourth quarter of 2018, and here we are getting a little bit nearer to the problem we are going to discuss, orders for $2,123 million, but we reached the revenues for 1,782. That means that our customers ordered us more than 2,000 million items, but we were able to fulfill them with 1,700. We will fulfill them in this year, so don't worry, but our shareholders would have preferred that we fulfilled last year for financial reasons. Okay, so the difference between these two numbers is $341 million, and the conversion rate, that is the rate between those two numbers, is 84%. So we were able to convert into money only 84% of the orders that we got. Why is that? This is because our supply chain has a lead time that is passing from the moment our customer is issuing the order to us. It's converted to an order to a supplier. Supplier has to produce the item, and then we ship the item to the customer. This lead time is responsible for the missed results. It's like from beginning of December to end of the year, we got orders that we were not able to close by the end of the year. So our scope was to reduce the lead time in order to convert more orders. How we do that? We do it with forecasting. So if we are able to predict what are the items that we need to have in-house to fulfill immediately when the customer is asking to us, this is reducing lead time by 70%, and then that 16% of missed conversion would go less than 5%. Everybody will be happy. But this metric is not good to measure an internal process. The good metrics that we use is the turns indicator. Turns indicator is the ratio between the revenue that we do and the average inventory that we have to keep to do that revenue. So, for example, if the forecast is good and it predicts an item that will be needed, and this item is sold many times, the average inventory is always the same, because the item arrives and goes. But the revenues will be multiplied many times, so the turns ratio will be high. And now we have to understand how to keep the turns high. So we can increase the revenues by raising the prices, not so good option for commercial guys, or penetrating new markets, but this is out of the inventory manager functional perspective, or develop new product. This is engineering. Or the second option is to reduce the inventory. We can do that. How do we reduce the inventory? By keeping the revenues at the same level, by choosing the right parts. And now I'm approaching the machine learning problem. The right parts, we call them MTS, make to stock parts, and the wrong parts, MTO. Wrong parts are parts that are predicted to be sold, but they are not sold. So they stay in the inventory, and the turns go down because this is the denominator. So MTO, MTS is a binary classification problem, and we developed an ensemble model to do that. And I leave the speech to Laura De Stefanis, our machine learning expert in the company. Laura?
Okay, thank you, Ciro. I have this one. Okay, so as Ciro was mentioning, we applied machine learning to basically to decide which item we want to keep in our inventory. And it's a decision that is quite crucial for us, because if we have a lot of items, then we are ready to serve our customers. As soon as they ask, they can give them items. But at the same time, we are investing a lot of money to build up this inventory. So it's not a good choice. On the other side, if we have very few items in stock, we save money because we don't buy items, but at the same time, we are not able to serve our customer. So there is a trade-off in between where we can decide which are the best items to keep in our stock. To face this issue, we decided to apply machine learning. Before telling you about machine learning, I will just give you some words about the process before machine learning. So we have to consider that not all people in our company are machine learning experts. So they were spending a lot of time in deciding which item we should keep in our inventory. And this process took more or less 1 month. So it's a month of work where people validate the results, do statistical calculation, merge Excel file, do queries on SQL, and so on. So it's a long job, takes time, and it also makes some error because of the human validation. And that's the main reason why we decided to try machine learning, and also because we like it, but it's a different story. So we use two, let's say, types of machine learning. One is for the part classification parts, and we used a supervised neural network to represent a classification made by human beings. And the other one is the reinforcement learning approach to find the best stock levels. So which is the best quantity for each item that we should keep in our inventory. Regarding the first part, how we applied machine learning. So it's quite straightforward. We started from the data preprocessing. So consider that we have more or less 200,000 of different item parts that we have to classify. And we consider 6 years of history. So it's quite a long data. And we manage all of that with Python, integrating our SQL queries, Excel files, and so on. So everything is conveyed into Python. Then we had two choices. Or we can do feature extraction and then machine learning model, or we can do a full deep learning model. So push all the data inside the model and see the results. At the end, the accuracy is the same, 99%. So it's not bad at all. But we decided, maybe surprisingly for you, to use the feature extraction and then a simpler model. And the reason is basically non-technical, because we prefer this model just for the sake of interpretability. Because you have to consider that the result of this model will be used by people who is not expert. And sometimes when you propose machine learning model to people who are not expert, I don't want to say that they don't trust it, but at least they are a bit skeptical, you know, because it seems to be a black box. So they start asking you, but why this one is classified in this way, why this one is the other, and so on. So we decided to keep the features clear so we can give an interpretation of the model, saying, you see, the cost of this item is very high. So that's mainly the main reason why the model classifies is and not to keep in stock. and also because the accuracy at the end was the same. So we did a lot of feature extraction, selecting which are the most important features like cost, price, or statistical indicators that tells us how many items are demanded by our customers. And then we trained our neural network that is developed in Keras with a bit of dropout and regularization just to avoid overfitting. And at the end of the story, we had a model that is more or less understandable also by other people and at the same time has a good accuracy. And we know which item we want to keep in stock and which one we can drop out. Then we have to face the other part of the story, so decide which items, how many items for each one we should keep in our stock. To do that, we use the reinforcement learning, which is one of the various techniques that you have to face this kind of problem. And we use that to decide which is the optimal inventory policy, where inventory policy means the levels of the items. So whenever we have, for example, 10 items in stock, whenever one is ordered, we go below and we decided to order again to reach another level that is safe for us, and so on. So which is the good trade-off? The answer is in the optimization of the reward function, so in the optimal policy. And the reward function is mainly made up of several contributions, economic indicators, like for example the carrying cost, which is the cost of having an item in stock without selling it, which for sure is a cost. You invest money and you don't give the item to customers. At the cost of purchasing the item, for sure. And then also the sales that you have when you sell the item. So we made up this function, we optimized that with the reinforcement learning, and we come out with the result of the optimal levels for each item that optimize the real economical value of that item. So we had an answer to both the problems, classification and decisional levels, and now we have to make these results available for the rest of our company. And that's the reason why we decided to do an application deployment that my colleague Amra, who is a PhD researcher from Scuola Sant'Anna, will show you.
So thanks Laura for introducing me. So here I will explain the deployment process of our application, and my goal was to create a Django application to allow non-expert user to use our app. So the Django application mainly composed of two applications. One is the query app. It's simply an app that accepts an SQL query and gives the user back a result. And the second application is the machine learning application, which is this is the flowchart of our application. So it accepts the machine learning application, accept the query attribute. The attribute, as Laura mentioned, is the cost, price, and some other lead time, some other attributes. And the query shipment is the demand history or the shipment history of that item. We have a filtering process. So first it starts by dropping the item with low hits. Hits mean that there is no shipment or no demand in the last year or very low demand in the whole year. And the second one is based on feature engineering, which is Laura mentioned, is the computing the confidence interval over T distribution, decide whether that item is regular or not, lumpy or not, and we drop that item. And what's remain is the item that we don't know whether they are, whether we should stock or not, called MTO, MTS classification. And this is the interface of, the main interface of the machine learning application. So so the user insert the training attribute, the shipment, and just press training. So once he pressed the train, we have something called a media folder that where the model, once the model is trained, it drops the weights of the neural network and the normalizer, just to use it for the test phase, because we don't need to renormalize this. Once you go for the test phase, the user simply insert a query, again, the attribute or the shipment, and get the result back, which is MTO or MTS item, the item that he should stock or not. So, and I have used Django, Keras, and Python pandas, of course. This is the things that I use to deploy my app. So I leave Laura to...
Yeah, just some conclusions, just to wrap up the results. So as you can see, this is a real application of what machine learning can do in a real company. We gained a lot of, let's say, advantages. First of all, we reduced the workload that we had in doing this process, and it's a good point for sure, because basically it was not adding a lot of value, doing stuff repeatedly and so on. Moreover, we were able to use new techniques and apply them. And as you know, machine learning, it's fun also because every time you train the model with new data that are validated again by users, the model improves. So in the long term, our model will improve anytime, and it will require less time anytime to be validated. So in a continuous improvement approach, we are going better and better. Moreover, we have integrated all the job into Python using Django, Keras, and other libraries, so that our end user should just push a couple of buttons to have the results, and it's understandable and usable by anyone. And it was also, I would say, fast, because sometimes when you have to develop code and application in a company, it requires a lot of time, and instead using Python and Django, we were able to manage them in quite a short time frame. Moreover, the process, starting from a process with a lot of jumps back and forth between human validation, Oracle, Excel file, Python, and so on, now it's becoming a single flow process. So you push the button and you get the results. And also this one is good because the risk of errors is mitigated for sure. And then finally, but last but not least, the inventory was optimized because we reached 15% of reduction in inventory. And that's mainly the reason why we are here, I would say. Okay, so I thank you for being here, and we are here for questions.
Thank you. It was very interesting. I will have a question about the resources needed to conduct such a project and the time you would need to from start until the end. So my question would be, how many people were working on this project, and how long did it take you to fulfill it?
Oh, actually, the three of us. So we were lucky because we proposed this project to our management, and we were awarded with a beautiful piece of hardware, and it is a powerful GPU where we could test different algorithms, and also we were able to deal with the different aspects of the project. So I was mainly translating the business instances into analytic problems that were addressed by Laura and Amr. And in the end, when the code was ready, we worked on the full stack application development, and this was done by Amr, basically. So now this approach is giving results, and this is moving the big ship, the big company towards this approach. Is also in other areas of the company. That is, in my opinion, the right direction for us.
Yeah. Hi. So, thank you for the presentation. It was really good. I wish you develop a paper to explain that, to publish, because it's really inspiring. Two quick questions. You said 99% of accuracy. How do you measure that? It means that out of 100 items, one you miss, the other 99 you have, I guess. The second question I have is also about the reward function. how did you weight each factor in this reward function? Thank you.
Okay, thank you for the questions. So regarding the accuracy, mainly it is measured compared with the human validation. So at the first application of our machine learning stuff and also for the training, we used the human validation to verify if the item was correctly classified or not. So for sure, maybe we missed one point that is very important. For good results, we needed domain experts. People who validate the results and say, yes, no, you are missing the features, no, this one is not correctly classified, and so on. And these people helped us a lot. And the good thing is that the validation part is decreasing. So as soon as we improve, it will require less time. But at the beginning, it's basically human validation for sure. And some other analytical filters, like for example, if an item it's very low demanded, maybe let's say less than 2 times in 60 years, we drop it and considering it as MTO. Instead, regarding the reward functions, basically the weight is due to the way it is built, the reward function itself. It means that we are considering exactly the cost of the item and the price of the item. So whenever you do an action in the interaction between inventory and customer, if you decide to do an action that is buying an item, you know how much you pay that item. If you sell the item because the customer asks you that item, you know which are the sales because you know the prices, the costs, and so on. You know also the lead time, so you can measure how long the item stayed in the inventory. So also the gain that you have in selling the item decreases because you had to keep the item staying there for a long time, and so on. So basically.
Sorry, I would like to add something. So the demand that we were dealing, the data stream that we were dealing with was very various. So there were items with a very steady demand. They were full of data, no problem in the classification. But other items were very sparse. So that means that in the time buckets that we decided, there were a lot of zeros. So, and this is a nightmare for every model. And this was the only way for us to understand if it was the case to keep them in stock or not. So the sparsity of demand is really the big problem for forecasting.
Thanks for the talk. Just a question. I don't know if you can answer, or maybe like corporate secret. But could you share like some details about the deep learning, like full black box architecture you used? Because I saw that you use Keras and some dance with dropout. And what was like the other architecture, like the full black box one?
Okay, so there is a backup actually slide to answer your question. We keep it.
Oh wow! Okay, thanks.
Okay, so there is the feature that was used, and also as Laura mentioned, it's a simple model because we relied on the feature. So we have reload activation function, the output activation function, of course, the sigmoid. We have we use the Adam, with the dropout. This is the value of the dropout. This is the learning rate, the number of layers that was used, the batch size, and the number of efforts. So this is the model that we use, and this is was an ROC curve.
So to clarify, this is the one that you use now in production, right? Or is this the one
this is the one inside the Django application.
Okay, I was meaning to ask you about the black box one. Like you said that this one used the feature extracted by your with domain knowledge, so to have more interpretability. Yeah. But then you also say that you tried with a fully black box one, which I suppose is just more layers, like a deeper one.
It's just more deeper.
Okay.
And more so it relies on the data itself.
Okay. Okay.
You inserted demand history, and you have Keras functional API that allow you to use the two inputs. So you have the features, you have the time series, and you train a more deeper model. And the accuracy was almost the same. We just decided to use a simpler model with the features.
Okay. Yeah. Also, one last question. Did you think about deploying the model with the TensorFlow.js?
No.
Okay.
I've used Django. So
okay. Yeah. Thanks.
Okay. As far as I understood, what you the outcome of your job was some kind of a decision support system, isn't it? Okay. So the user are people who are deciding whether it's the case or not to buy some item for the stock. Do you have some feedback about the user adoption, because you told that this was a thing to, and whether the people is actually following the indications given by the system?
Yeah, so yes, this is a crucial question actually. So let's compare the process that was used before that. Every half a year, we need to review the list of items that we decide to keep in stock, because demand is changing, and also in the last period is changing quickly. Okay, so actually this process is run. It was taking kind of 20 days to be run, and once the items list and the levels, as Laura mentioned before, is issued, there are some people that are inputting these values into our system. Okay, so at the moment, this approach is allowing us to improve the frequency of this calculation, and also follow the demand variations better. And the people that are inputting this value in our system are gladly taking the data out of an automatic system instead of copying an Excel file like it was done before. So that is.
So also thank you very much for the interesting talk. The reinforcement learning, did you just train it on the history data you had, or did you also put in an agent simulation to beef up the numbers a bit?
Yeah, it's a good question actually. We started and the things that are now done in production are done with the historical demand pattern. But for sure, for the future, we are working and researching to improve. Yeah.
Thank you for the really interesting talk. I'm not an expert absolutely in this domain, but the question is, does the change in demand requires for you to retrain the model? And so, because I didn't get it, in the application, in the back end of the application, the training is rebuilt from scratch every time that the user inputs data, or there are some moments in time in which you deploy a new model, and this is how does this happen?
Yeah, we use the last 6 years of data. So anytime we use the model, the time window shifts, and we do that every 6 months. But the demand pattern changes in the sense that the numbers inside this 6 years pattern changes, but we are not changing our model. We are just applying the model that we trained, and we do a short validation, shorter and shorter, and we retrain the model again. But we are not modifying the model. We are just updating the data. So I don't know if that was the question. Maybe it's not clear, or...
Yes. Thank you.
Okay.
Thanks for the interesting talk. Regards the last question, I want to know, sorry for the English, every time you push the button and retrain the model, the parameters are the last of the are the same of the last epochs, or you have to reset and restart the training. I don't understand the.
Okay, so I have just one answer. So if you decided to retrain the model. In that case, the weights will be updated. So you will have the weights of the new models. So the previous one will be a historical one. We're going to use the new one, the new weight. I don't know if that answers you.
The new weight. The new.
The weights of the neural network that save the model. So when you save the model,
okay.
you will have the new one
So
to be used for the future.
So the weights are restored from the last
Yes.
iteration.
So usually this train process, we don't do it every time. So the user should not use this. The train. We retrain the model. The user sees only the test phase. Means that they use the weights that's already dropped in the media folder inside Django application. Okay.
Okay, thanks.
Quando usiamo il modello,
Se parli.
quando usiamo il modello,
Grazie.
non c'è problema. Quando usiamo il modello, l'utente utilizza la fase di test, quindi il modello è già trainato, i pesi, i parametri sono tutti già fissati, l'utente lo usa e vede il risultato. Valida il risultato, se c'è qualcosa che non va e quindi il modello fa tanti errori, a quel punto ritrainiamo il modello e modifichiamo i parametri, altrimenti se va bene meglio.
Certo. Cioè, chiedevo se con altre osservazioni si ritraina il
Sì,
modello.
se c'è
e
molta
quindi si
discrepanza fra la validazione
Ok.
umana e il risultato del modello, ritrainiamo il modello.
Ok.
Ovviamente non succede tutte le volte che lo usiamo, perché la maggior parte delle volte va bene così, quindi usiamo il modello già fatto.
Ok, grazie.
Just a curiosity. If, I don't know if it is the case, if you encounter it, if a new article is added to the logistic process, you can generalize a bit, or you have to do manually for 6 months.
So this is a problem that we addressed with the function that is called chaining. So there is the chaining of the code. So if a new item is added, which is the new version of an existing code, all the demand of the previous versions of that item are linked to this new name that the code has. And so there is no problem, because this item is a new item, but the demand stream, the pattern, is already there. If the item is really a new one, and that is a lot of what we were mentioning before, actually, if it doesn't overcome the parameters to be classified as MTS, as I mentioned at the beginning, we will not stock it, because it's risky. Or we, and this is something we are working on, forecast what will be the future demand for that item because of the market conditions, and use that pattern to classify.
Okay.
So, but this is, thank you. It's
So I think the high number of questions, which was quite impressive, shows the level of interest in the project, and we want to offer thank you for sharing this information, this presentation.
Thank you very much. Thank you.